Today we are going to look into the implementation of the performance evaluation matrices. So we talked about two matrices, ROC, AUC curve, and we also talked about confusion matrix. Now to summarize them, confusion matrix for a data where the target variable has two classes is a matrix of shape 2 cross 2 where we have true positive, true negative, false positive, and false negative cases. So out of the total prediction that a model might have made, a confusion matrix is the comparison between all the predictions that are correctly made by the machine and the predictions which are faulty, which are the wrong predictions. Okay, so this is the information that we were able to convey with the help of confusion matrix. Now talking about ROC and AUC curve. So ROC means receiver operating characteristic, and AUC is simply area under the curve. We talked in depth about what ROC is. However, we did not discuss what AUC is. So we'll be talking about what is AUC, and it is not that hard to understand. Okay, like the term says, area under the curve. It is simply the area under the ROC curve. So we will talk about what is its significance with respect to any model. But first, let's revisit what we studied with respect to ROC. So for every classification model, okay, so all the classification models, they return probabilities. Okay, so they never directly predict in which class the data should fall. They predict the probabilities first. And then we do what? We set the threshold. So based upon the threshold, we divide whether something belongs to class A or class B. Now, when I run my model for the first time and I set a particular threshold for it, let's say 0.5, I'll be able to classify some of the data into class A and class B for a data. Now, once I have got my predictions, what do? I compare it with the actual values. Okay, the y test that we have. Now, for every comparison between prediction and test data, we might be getting some values, okay, which are not correctly predicted. Again, some values which will be correctly predicted. So for one prediction, we will again be able to construct a confusion matrix. Okay. Now this confusion matrix is going to help us to calculate two things, the true positive rate and the false positive rate. So true positive rate is the comparison between the true positive cases and all the positive cases. Okay, so true positive, the cases that the machine correctly predicted, and all the positive cases, which are true positive plus false negative. Similarly, false positive rate is the comparison of all the predictions that are wrongly made by the machine, false positive, divided by the total scenarios. So false positive and false negative. Okay. So let me check the formula once if I'm writing it correct or not. Sorry, it is true negative. Okay. Now we also concluded that this true positive rate is nothing but the benefit that we are getting from the model. It is everything that is correct with the model, the predictions that it made rightly. And this is the cost of the model. And we always aim at maximizing the benefits and minimizing the cost. So for every time the model has generated some kind of predictions, what do? We calculate the true positive rate for and the false positive rate. and we plot all of it. Okay, so for one particular data, okay, for the number of times that you are running the model, you'll get some true positive rate and you'll get some false positive rate. And you are going to plot a curve between them. Let's say for the first iteration, the false positive rate, true positive rate is this. Then these crosses, they are denoting the true positive and false positive rate. So all in all, what do you get? ROC is nothing but this curve that you are getting right here. Okay. And this curve, it conveys two information. Let's talk about those information. So ideally, the true positive rate, it should be 100%. And false positive rate, it should be 1. So the ideal value for true positive rate and false positive rate in this graph would be 0, comma 1, because we have false positive rate on the x-axis. So if we speak ideally, since just let me change the color, since this value of true positive and false positive rate, it can range between 0 and 1. So somewhat right here, this should be your ideal value for true positive rate and false positive rate, where false positive rate is 0, true positive rate is 1. So what do we do with the help of this graph? We basically find the point, okay, that is nearest to this point, and we use that point as the threshold. What kind of threshold? To classify the data. Okay, because we can use several threshold, but this threshold, since it is closer to true positive being equal to 1 and false positive being equal to 0, sorry, this is 0. So this is my optimal threshold. This is the first thing that is conveyed by this particular graph. Then many a times you will also see there is a reference line drawn like so. Okay, and you will also see that there is another line that you guys might find. Okay, so basically this whole thing, okay, this whole thing, this is called area under the curve. If I have multiple classification models, then I can plot ROC and AUC for all of them, and it is going to help me to demonstrate which model is the best fitted model for the particular data. And the model which has maximum area under the curve, that is the best model. Also, this reference line, it is nothing but it is just dividing your area under the curve between two points. Okay. And basically, we aim at getting all the probabilities in this half. Okay. Since everything would be like crossing the threshold, all the points that are coming under this curve. Okay, so this is what this is, ROC and AUC. Please give a thumbs up if you guys understand and if you are able to recall what all matrices we studied in the previous session. All right. Now today we will be majorly focusing upon the implementation of these things. So if I talk about the implementation, sure, I'll be using Plotly. This is the documentation of Plotly. And if you are planning to draw ROC and AUC curve and you want to basically use Plotly for that purpose, you can simply search for ROC AUC Plotly and you'll get the documentation. How does these documentation help? They have all the predefined code. Okay, so they can tell you in what manner you should write the code and what is the procedure that you should follow if you want to draw a similar graph. So if you scroll to the bottom, they'll tell you that this is the kind of graph that you can draw. When I hover over this graph, I'm able to receive the information such as true positive rate and threshold value at each point. Okay. If you scroll a little bottom, you will also be able to see another kind of graph. Then here, like if you scroll further, you will be seeing a graph that contains various ROC curves. Okay. And for Setosa, versicolor, and Virginica, we have calculated area under the curve as well. Okay, again, this area under the curve, it could be a quantity between 0 to 1. 1 is the maximum area under the curve, and as closer as the value is to 1, the better is the model. Okay, so you can take help of this library, and if you want to plot a much interactive ROC-AUC curve, well, you can use Plotly for that matter. Now, it is not necessary that you'll use Plotly only. So ROC-AUC, Matplotlib. Okay, so here, let me just visit another link. This is for Stack Overflow. Yeah. So this is the ROC and AUC curve that is drawn using Matplotlib. So it doesn't matter which library you are using, but you can see that the Matplotlib ones, they are not as much interactive as the Plotly. So we'll be using that. And in Seaborn as well, you can use the functions to draw the ROC-AUC curve. Okay, so coming back to this documentation, this is a very handy documentation, and I'll be using this as the crux of today's implementation. So I'll explain everything. We will be aiming to draw a graph like this and a graph like this one. Okay, and see, if you are drawing the graph as is, okay, we used several plots and earlier in the Python, when we were talking about Python, so we went through this library and we drew various graphs. Most of these graphs, they are interactive. You can zoom in, zoom out, you can hover and you'll get to know about the values. But sometime when you want that the values that you see here, okay, they should be customized. Okay, you don't want to see all the values. Maybe you want to highlight some particular points in your data. So these things, they are called traces, and you can define these traces on your own as well. So we'll be doing that. Okay, so without further ado, let's just start with the plotting part. Now, please do let me know who is going to code along with me so that I can lower down the pace a little bit. Is there anyone who is going to code along? Okay, no one doesn't matter. I'll code and you guys can have a look at the implementation. Okay, Modhaj will be coding. Himanshu as well. All right, guys. Do let me know when you finish up writing the code. Okay, I'll be giving you ample of time. All right. So let's start. And I'll also provide a CSV file now. Just give me a moment. I'll have the file in the chat box. Let's start by importing the necessary packages. I am going to import NumPy, also pandas, import matplotlib because we'll be using matplotlib as well. Sklearn linear model. We will import logistic regression. And from sklearn model selection, we will import three tests here. With sklearn.metric, you can also import confusion matrix. Right, these are the necessities. Please import them, and once it is done, please also import the data set and give me a thumbs up. Meanwhile, everyone else can look at the data. This is how the data looks like. Okay, now everyone else who's not coding, can you guys tell me that if I omit the data pre-processing part, then what should I do next? Let's say I have the data that I have over here, it is already pre-processed, which means I do not need to perform any kind of cleaning. Then what are the steps that I should perform if I want to train my logistic regression model? Okay, and before train test split, is there anything? Encoding is also data pre-processing only. There is one little step that you guys are forgetting. Also, this data does not require encoding. It is completely numerical. Mordhaj and Imanshu, are you guys done? Okay. So once the data frame is loaded, and if we believe that pre-processing it is done, the first step that we do is that we split our features and we target variable, which is to divide the set into X and Y. So this is the data. And I'm going to consider that this default column right here. This is going to be my target. Okay. And everything else is going to be my features. Okay. So student, balance, income. These are my features and default is my target. Let's just see how many values are present in my target column. So VF dot shape. This is the shape of my data set. And DF default dot unique. I have these two values. And if we do n unique, we'll add two values. And if we do value counts, we get that there are 9,667 classes that belong to 0, and there are 333 values which belong to class 1. Mordhwaj and Imanshu, you guys also check if you are getting the same result. Shall you proceed, guys? Mordhwaj and Imanshu? Okay. All right. So, though there is nothing wrong, I can proceed with splitting my features and target variables and then continue with the train test split. But you can see that in my classes, there is a very massive difference. Okay. So, I have more samples belonging to class 0 and I have very less samples that are belonging to class 1. Now, if I perform train test split, then the model, it is going to be the model which will be trained upon this data, it is going to be biased towards this zeroth class because data belonging to this class is present in more quantity as compared to class 1. Okay, so there is a technique that we call smooth. And Basically, this thing, it can be treated. Okay, so if there are samples belonging to one class, which are more, like way too much more than the samples belonging to any other class. So this thing, it can be like, it can be treated by either oversampling a class or undersampling a class. So what do we mean by oversampling or undersampling? Oversampling simply means that increase the number of samples for the class which has less samples. That is, I'm going to generate some synthetic samples for this class. And undersampling means that's the opposite of it. You can take away some of the samples from this class. But you can see, like, if I take away the samples from class 0, my data it is going to get affected. So it is better to perform oversampling. And if you want to perform oversampling, there is this technique which is called SMOT. So right now, we could perform it, but we will understand an algorithm before we perform SMOT. So let's keep it reserved for the next sessions. For this particular implementation, we will proceed with this data. However, it is wrong, and you should make sure that both the classes they are equally represented and there is no bias in one class. Got it? Do you guys understand it? Why we need to do oversampling or undersampling? Okay, so let's get back to our task, which was to divide features and targets. So X is going to be my columns without the default column, since this is the target point, and Y is going to be my target column. So this this is X and this is Y. Forward and Himal, to please write this code and let me know when it's done. All right. Once it is done, now we can finally perform the train tests later. Okay. So let's use the function provide X and Y. Provide the size of test data. So 0.2 it is going to be. And also you can keep a random state. I am defining the random state as let's see. And this will give you explain X test Y green Y. We are not normalizing the data. Normalizing as in that perform oversampling or undersampling to fix it, or basically the normalization that we talked about in pre-processing. Which kind of normalization you are referring to, Paris? Okay, so there are lots of steps for pre-processing. And I told you guys that we will be focusing on the implementation with regards to ROC here. And we'll assume that data pre-processing it is already done. Also, it would be good to check the null values because that is kind of compulsory. The model won't generate the output otherwise. But all the other steps, such as normalization and scaling, without that, the model can work. So it would be better that if we focus and if we devote the time towards implementing ROC and AUC and skip the processing part steps currently. In all the demonstrations that I'll be showing, we are going to skip these parts. Okay, because then the demonstration, it is going to like consume a lot of time. Also, if you want to know why we are not performing SMOT, because before explaining SMOT to you, I need to explain one algorithm uh, by the help of which this technique is generating synthetic samples. Because you cannot simply add some data and you can see, say that now the data that you have added, it has balanced the classes. Because you need to generate samples considering the overall data in mind. So there is an algorithm which we will understand and then we will implement SMOT. Okay, so once you basically get this data, okay, once you basically are able to form the model for this data, you can simply do one thing. You can check the accuracy, and then when the class is over, you can pre-process the data and then again train the model and see what is the difference between the accuracy. These things you can do after the class. All right, so let's proceed and let's train the model now. I hope your doubt is clear, guys. Okay, so let's proceed towards training the model. I am using logistic regression function to construct a logistic regression model for this data. Since the default or the target column of it is of categorical nature, which means the data, the predictions that are needed to be made, they should be either belonging to class 0 or class 1. This is a classification problem. So let's fit the explain and wide range. Now, please recall one thing that when I told you how ROC is able to generate the curve for each and every model that you create, we talked about that all the classification models, they return some kind of probability. So please remember that earlier we were using this function, predict function, and this would contain a best case, X test, and this would simply generate the Y predicted directly. Okay, because we were explain is not here. Okay, just give me a minute. Yeah. So we were not concerned with these probabilities earlier, but right now we need these probability. We need the probabilities based upon which the model is defining these class in order to plot the ROC curve. So we will use a different function that is called lr.predict underscore prob A, and again you will pass its test here. When you run it, you will see that you get two values. Okay, for each and every class, for each and every data, you get two values. Now, one of these values, if you create the docstring, I guess it will be demonstrated here as well. Yeah, here you see the returned estimates for all classes are ordered by the label of classes. Basically, by each and every label, you get the probability estimates, and it returns an array-like shape which contains the probability of the samples for each class in the model. Okay, so basically, whatever is the probability of a class belonging to, let's say, for a data belonging to class 0 or class 1, both the probabilities are present over here. So what you guys can do, you can slice either of the probabilities. Okay, either you can slice these ones, these probabilities, or you can slice these probabilities. One of them is the probability of belonging to this class, and another value talks about what is the probability of not belonging to this class. So here I am slicing the first column, basically this column. This is the zeroth column, and this is the first column. So I'm slicing the first column out, and this gives me the probabilities. So let's call them y predict probabilities. And here they are. Do you guys understand this piece of code? How we generated probabilities and why these probabilities are necessary? Okay, Modraj and Himanshu, please write the code and let me know when it's done. Okay, just give me a moment. Okay, so since we have got these probabilities, we will use y predict later. We can check the accuracy as well for the model. So scalar dot matrix import accuracy and you can pass y test and y prediction. And this is giving you 97.6% accuracy. Now, this accuracy, okay, let me take some time to explain you why the accuracy is high despite not doing any normalization, any scaling, and any kind of oversampling. So basically, the data sets that I provide to you, most of them, they are already pre-processed because I have taken these data sets from Kaggle. Okay. This is the site where you find the data sets, and I also have the code for some implementations. So the data sets that are present, most of these data sets, they are clean, devoid of any kind of inconsistency. So that's why the accuracies that we are getting, they are very high. We get 80%, 97%, 99%. Once you will also see that you'll get 100% accuracy. Okay, in one algorithm. So it doesn't mean that it is that much easy to attain, to achieve this accuracy with the real-time data, because that data, it is uncleaned to another level. You need to clean it, you need to pre-process it, and despite uh, cleaning and pre-processing, still you will not be able to achieve this high accuracy. Hardly 60 to 70% accuracy can be achieved on that data. Okay, because that would be such a massive data to deal with. So please don't let yourself believe that maximum to achieve maximum accuracy it is quite easy task. It is not. All right. So we got an accuracy score which is 0.976. Let's just also see what are the true positive and the true negative cases for this data. So for that purpose, I am also going to import CMOD and I'll plot my confusion matrix. And first, let's use the confusion matrix function and provide two things. So it will be taking y test and y predictor. This is the array that is generated for you, which denotes the true positive, true negative cases on the diagonal. So these 920, 1925, this is the true positive, this is the true negative, this is the false positive, this is the false negative. If you want to plot it, you can store it inside a map and you can use the heat map function that was used to plot the correlation graph. So you can use the same function, pass your matrix, use the anode parameter so that these values that were generated, okay, these values, they also get reflected on the graph. And this is how your heat map will look like. You can also do one more thing. You can provide formatting here so that the values, they have the same format. So here I'm specifying 0.2f, which means the two decimal places after the decimal showing the value. Okay, so this is the confusion matrix. You also see a bar on the extreme right side. If the color is dark, the value is very low. If the color is light, the value is very high. So you can see that for this particular model, the true positive case, they are, they are of higher number. The true negative case, they are of very less number. And similarly, false positive and false negative are also very less. But we got the accuracy as 97%. So if we go by the accuracy, we should also be getting in true negative cases in more number. But you can see that this model, it is biased towards the true positive cases. So please recall that we talked about overfitting. Okay. Now, overfitting means that the model is performing very well the training data set. But if you provide any value from the random, the model won't be able to work for it because it is learning too much in the training process. And whenever you achieve very high accuracy, okay, even without any pre-processing steps, even without trying that much harder to construct the model. So one thing that you should always believe is that the model, it might be overfitting. Okay. So what are the steps that you can take to basically deal with this overfitting problem? So you need to first perform, you need to first check whether the samples they have equal representation. You need to actually perform all the data pre-processing steps that we skipped. You can also check for outliers as well. So all of these things they deal with overfitting to a lot of extent. Please give a thumbs up if you guys understand everything till here. And also imagine what you guys can copy the code and check it yourself. Everyone else, do you understand the heat map, why we have drawn it, the confusion matrix, what it is conveying, and why the accuracy is more for the data? Okay. So overfitting, let me just take you through the example that I gave earlier. Let's say, okay, so let's say we are creating a model that is going to take whether an object is born or not. Let me just take you back to the. Okay, just give me a moment, I'll explain it. Acha, Modhwaj doesn't want me to draw anything on the whiteboard. Do you get it, Modhwaj? I can explain without drawing as well. All right. Yeah, so if you can recall that ball or not example, you'll be able to distinguish what is overfitting. However, just to summarize, overfitting is the condition where the model performs too well on the training data. Okay, it hugs the features and it is not able to perform very well on the testing data. Okay, and the situation, the conditions which can basically pertain to overfitting are that we can see that in our data we have more samples belonging to class 0 than class 1, and we have not even performed the data pre-processing steps. All right, so let's plot a simple ROC curve for this data. For that purpose, we need to calculate the false positive rate and the true positive rate as well. So from sklearn.matrix, where you have imported all the necessary things. Here you can also import ROC underscore AUC underscore curve. Firstly, just import ROC curve. We'll talk about AUC in a bit. Import this function and go to the bottom again. And then you can pass the data. So we are going to pass y test and we are going to pass y. And if you read the docstring for this function, let's go to the bottom. So this is going to compute a receiver operating characteristic, and this is restricted to binary classification task. I already told you where you have to divide your data into two classes, and all the classification models are capable of generating the probabilities, and so you can draw the ROC curve. Okay, so what it is going to return? It is going to return three things. It is going to return false positive rate, increasing false positive rate such that element I is the false positive rate. Okay, all the things that we have studied. True positive rate and thresholds. Okay, so it is also going to return you the threshold for which this is the false positive rate and this is the true positive rate. Please relate to these concepts or relate these terms with what we have discussed before. So in this particular order that I got from the docs, I'm going to write false positive rate, true positive rate. These are the two things that I'll require in order to plot the ROC curve. Thresholds are not that much important. So whenever a variable that is returned by a function is not of much importance to you, so rather than giving it a variable name, you can add placeholder that is underscore. So in that manner, the function won't be generating any kind of error since you have given it a placeholder and you do not need to think about what should be the variable name if you're not using it. Okay, basically this also indicates that anything which is inside this underscore, it is not of much use for this implementation. But it doesn't mean that you can't look at the values. So it gives you these values, and let me just calculate the positive rate and the true positive rate as well. Okay, we are getting only three values here. Let me see what is going on wrong. Okay, I need to provide the probabilities. Since ROC works on the probability, so do not provide the predicted value, provide the probabilities. Let's check what was the variable that we used. This one. Yeah. So this is the false positive rate. Yeah, now we are getting method. This is the true positive rate. And this is the threshold. Okay, so changing by making a very minor change in the threshold, it is generating more threshold values, and for each threshold, we are getting the true positive and the false positive rate. All right, please write this code, Urdhwaj and Himanshu, and give me a thumbs up when it is written. In order to plot, you can use plt.plot function, but we will use the matplotlib. On x-axis, I'll provide false positive rate. On the y-axis, I'll provide true positive rate. Let's also get the label. True positive rate and false positive rate. And simply do plt.show. Okay, this is a simple ROC curve for this model. We just zoom out a bit. Yeah. So this is the simple ROC curve for this model. You can see that this one indicates for various thresholds what is the true positive rate and the false positive rate. One more thing that it is that is observable here is that the area under the curve is very large. However, we do not know the exact value. We will calculate the value in some time. One more thing that is observable from here is that if I hover on this graph, I'm not able to get any extra information. That's why we are going to plot the next ROC curve using plotly. If the data was more, okay, this curve would be very small. If the data is less, the curve is little bit rough. Okay, so it is not always the case. However, the curve will look like this, but not always these aberrations that you are seeing right here. Okay, not always these aberrations will be the same. They will depend upon the data. If data is less, then you will see more roughness. If data is more, you will see a smoother curve. Okay, please draw the curve and give me a thumbs up. And we are going to take a 2 minutes break, after which we will continue. All right, let's take a short break and we will continue after it. All right, do we have everyone here? Okay, so let's resume with the demonstration. So firstly, let's see what would be the area under the curve for this particular model. So let's go back to the place where we have imported the matrices and now we will import ROC-AUC curve. Let me check what is the name of the function. ROC-AUC square, sorry. Okay, so from sklearn.matrix to import ROC-AUC score, this will allow you to calculate the area under the curve. Okay, so let's use the function. And the drill is same. Provide your test, y-test and y-test probabilities. And as a result, we get 0.95 as the area under the curve, which is quite high, which means that this particular model, logistic regression model, is working well for this data. Okay. Now, in order to learn more about how to plot ROC-AUC for different models and how to basically make it interactive enough using Plotly, we are going to do another, we are going to create some more plots and we will be dealing with a new data. For that, I have mentioned the link in the comment section. Please give a thumbs up when this is done so that I can talk about the next demonstration. Okay, so anyone who is coding, feel free to use the link that I have provided. This is a raw data that we have. Okay, and it is containing information about pregnancy, glucose, blood pressure, skin thickness, insulin, BMI of different people. And based upon that, it has this target column, which is outcome for which it is telling whether the person is liable to have diabetes or not. All right, so we will be generating a model for the same data. And you can either create a decision tree model. Now I'll be creating logistic regression for this code as well. But if you want, you can create a decision tree model because that is also a classification model, or you can create a random forest model as well. Okay, so that we can see what is the accuracy of different models. All right, refer to any of the notebook that I have demonstrated earlier, and you can implement either decision tree or random forest upon this data. I'll be doing logistic regression. So let's import everything. This is the data set. Okay, let's perform few of the steps quickly, such as loading the data set and dividing into X and Y and performing train and test state. So X column for this data is going to be the outcome, everything other than the outcome column. So let's get it. And the Y column would be simply the outcome column, which is telling whether the person has diabetes or not. Once you have it, you can train test split upon your data. Let me just get the above code only. This is the code. And if you want to know the shape, it is better to display the shape of the data as well. So shape, not shape. So these are the shape for training and testing. Similarly, you can check the shape for Y train and Y test as well. Let's create a logistic regression model. So again, I'm going to the top and I'm copying the code. Now, though we are not using much of the parameters that logical regression have to offer, there is one parameter that is max iter, which is set to 100. Let's use this one for this model. Now, this parameter, basically what logistic regression do, it aims at finding the optimal value where the classification that is happening, it is going to be the best classification. So this thing, okay, finding the optimal value for the function, it is an iterative process. And by default, this function, it's going to run 100 times to find the optimal values. But if you want to change these iterations, so you can use max iter. Let's give 1000 iterations. Now the function, it is going to run 1000 times iteratively to find the optimal value. If in these 1000 iterations it is able to find the optimal value, then okay, it's fine. But if it doesn't find, then whatever is the best value or the last value, basically what is the value of the last iteration, that will be returned. Okay, so here they are using max iter so that the function it iteratively uh, basically improvises itself over these 1000 iterations. Then obviously we are going to perform the fit upon the model, X-train and Y-train. And if you want to have a look, this is how your fitted object will look like. And again, you can get the probabilities. So these are the probabilities. Okay, that you get for this model. Now let's plot the ROC curve. For that, I need to get the value for false positive rate, true positive rate, and threshold first. So my test and Y probability. And this would give you false positive rate, true positive rate, and threshold. Here I am giving threshold a variable name because I'll be using it in my graph. So it is better to have a variable name for threshold as well. Now, Modred and Himanshu, have you created a model for yourself? Himanshu, please let me know if you have created a model. Okay, so let's plot. So for plotting purposes, we are going to import Plotly. And from Plotly, we will import a module that is called graph objects. And we will define an alias go for this particular module. Now, once this is done, please record. Okay, so let me just take you back to the graph. Let me just show you the documentation as well. All right, so here you can see that this is the graph, and I intend to draw same graph. But since ROC-AUC is also used to know which is the most optimal threshold, so in order to give that much importance to threshold, I'm going to point. Okay, I'm going to denote and specify few thresholds here as well. Okay, so just like milestones on the road, I'm going to put some threshold points here on the graph. Please give a thumbs up if you guys understand it. What I'm trying to say. Are you able to comprehend? Okay, so this one it does not. It is only talking about false positive rate and true positive rate. No information about the threshold. So I'm going to denote the threshold as well on my graph. And if you go and read the code a bit, here you will see that there is area function to add the information, and here they have explicitly written what they want to basically signify on their graph. So ROC and AUC is displayed right here. And if you go to the bottom a little bit, here you will see some functions. Okay. Basically, these functions, okay, these are used to define the trace. What is the trace? What are the values that you're able to see here explicitly? So let's do it for our graph as well. Just a moment. Okay. So I'm going to define three traces for this graph. So firstly, it's going to be for the lines. Okay, the line of the ROC curve, then to mark the threshold points, and then to denote the area. Okay, basically the reference line that you can see from the bottom left corner to the top right corner. One trace would be for that. So please write the code along with me and I'll explain when it's done. So firstly, we will write the code to generate a trace for ROC curve. I'll call it trace 0. You can use any other variable of your choice. We will use the core scatter function to plot the trace. And here it is going to take some values. If you want to know what are these values, just press Shift and Tab, and you'll be seeing the doc string for this function. So you can take some time to read the doc string, but I know what all values I'm going to give. So you'll be the false positive rate, the true positive rate, and what is the mode? Okay, by what way I want to show you these two things, basically the false positive rate and the true positive rate. For that, we have a parameter mode. So here I want to indicate these things by the help of lines. And what is the name that I want to give to this trace? I'll give it ROC curve. This is a string, it can be anything. This value I have provided. You can look for the doc string and you'll find several values that this mode parameter can take. Right. Now, firstly, what I'm going to do, I am going to calculate, since I'm plotting the thresholds as well. I need to indicate thresholds on my ROC curve. So I need to get all the number of thresholds. Basically, we have thresholds array. And what I want to do, I want to get what is the length of this array. So we have total 56 thresholds. And what I want to do, I want to generate an array starting from 0 to 55. Basically, I want to denote all of these thresholds with an index number. So that will help me to plot the threshold only using the plotting library. So these are the threshold indexes that we have generated by getting to know how many thresholds are available to us. So let's define trace one. So this trace one is going to be for thresholds. We call it trace one, and I use the same function that is trace pattern plot. Again, I need to provide the value for threshold. Please notice one thing. Here I'll be plotting the false positive rate and the true positive rate as well. And for that particular point, for that particular value of LPR and TPR, I should have a threshold also. So for X, I'm going to pass FPR. Let's just use this in the main code. We'll call it indices, since these are the indices for thresholds. And here we are going to pass all the indices after that. For each and every value of FPR, I can plot the value for X. Similarly, for Y as well, I am going to the true positive rate. And I'm going to pass the list of indices. What is happening over here is that if you go to FPR, and if you index out the zeroth position false positive rate, and if you index out the zeroth position true positive rate, this is one coordinate for plotting. Again, if you do the same for something which is at first index, so these are the second coordinates for plotting. And they will also have a threshold value associated with them. So we will be plotting these 2 points, and for these 2 points, we will be signifying the threshold. So that is what I am passing here. Now, what would be the mode for this particular trace? So here I'm writing markers plus text. What do we mean by markers plus text? Like I want to denote these threshold with some kind of marker, and I also want to write a text for it so that I can convey what is the actual value of threshold. Right here, you are going to give it a name. So I call it threshold points, or better to say threshold points. And you can see that in mode, I have defined the markers and I have defined the text. So I need to provide this text as well that I want to see when I hover over these points. So use the text parameter. Here we need to define, we need to associate with each of the point, we need to associate the respective threshold, which is basically this for point 1 and this for point 0, this for point 2. I need to do this iteratively, and whenever we need to do something iteratively, we use a loop for that. So since this is a parameter, it is better that I write a list comprehension for it, and list comprehension is nothing but a for loop with one single line. What we are going to do for set value of thresholds in the thresholds. Okay. And indices is the list of the thresholds that we have passed so that we can index them out. What we are going to do, we are going to write the representation that we want to see for these thresholds when someone hovers over it. For that, I am writing it F string. It is a format string, so we are going to see say threshold equals to and whatever is the value in this variable for that threshold. Basically, if to summarize it in one thing, so this is the value that I'll be getting for 0th index, and this is the value that will be copied here, and then I'll be able to see it in my graph. You can also define format for this. So it will 2 decimal places. I want to see this value. And this whole thing you can pass like here. And again, there could be a parameter that is text position. And you can simply say where you want this text to be seen. So I write it top center. All right, now we need to define trace 2 as well, but please look at this code, whatever we have done till here, and take some time to have a look at it and let me know if you have understood what we have done so far. Okay, so let's quickly plot the graph. And once we get the graph, it will be much more understandable than us. I am omitting trace 2 for now, which was for the diagonal line. We can quickly pass the data for all the traces and create a list. So pass trace 0 and trace 1. Because these are the things that I want to do with on our graph. And here I need to define the layout for them. So we use a function that is called line layout. And here we are going to provide all the necessary things such as the title for the graph. We call it ROC. Then the x-axis values. So what is the label that you want on the x-axis? This is going to be a dict. Okay, the parameter value will always be a dict. So here I am simplifying it as title, which is going to be the key, and the value would be false, positive, fake. Similarly, for y-axis as well, we will define the title and we change the parameter and instead of false, like true, positive rate. Other parameters that you can define here is you can define the width of a graph. I need to define a depth and like a graph. Like skip 900. And these would be the parameters. I'm going to store that inside the function or variable called delay. and use the figure function to actually show the figure. So here we will be passing data. Data is what the two traces that we have defined. And then there is a parameter called layout, where we are going to pass the layout of our graph. Simply store it inside a variable. And finally, we can see how the graph looks like. This is the graph. Let me just zoom into it a little bit. So you can see that each and every point we are able to get the threshold and the true positive and the false positive rate. Here we also get a legend which denotes that the blue line is the ROC curve and the red dots, they convey the threshold points. If you want to reset it, which is the option auto scale, yeah. So this is your whole graph. Comparatively, is conveying more information. If I want to tell you, okay, let's just zoom into the graph a little bit. Okay, so here, let's see what all thing in the graph is represented by which part of the code. So here you can see we are able to see the threshold and the true positive rate and the false positive rate. If you go back to your code, this is the code that we wrote for this purpose. You are getting the true positive rate at the zeroth index, the false positive rate at the zeroth index. We have defined mode as marker plus text, which means I also want to see these threshold values marked, and I also want to denote some kind of text so that here the value, the threshold, it is available to me. This thresh equals to 0.24. This is defined here. For each point, you are able to loop through the thresholds and you are able to display them. The text position top center that you have defined. And this trace 0, this is for the line that you are able to see right here. Here you do not see any kind of text when you hover over the line because when you have not defined any text here, we have text parameter here in this trace, but no text parameter here. So if you want to denote these values when you hover over here, you have to explicitly define them. All right, but you get the false positive rate and true positive rate plotted by this particular trace. One thing that you guys can observe here, okay, is that the graph, though it is conveying too much information, but it is a bit clutterish. So what you guys can do to reduce the clutter, instead of plotting on the thresholds, let's plot every 10th point. So let's go back here. And what I'm going to do, I'm going to plot, I'm going to divide this whole data with 10. And wherever the value is equals to 0, I'm going to plot it. What do I mean by this? I'll simply show you. Okay, so earlier we had this particular array, and when I divide it by 10, okay, I get the remainders. And if I put a condition where the value is 0, you can see it is 0, here it is 0, here it is 0, which is every 10th observation. So I get a value of true and false. And this particular thing I'll be using in order to reduce the clutter on my graph. Now you can see that every 10th point is only getting plotted. And the graph is much more good to look at. All right. Do you all understand this particular demonstration? Is there any kind of doubt you wish to ask? Please give a thumbs up if you understand the demonstration. Okay. So In tomorrow's session, we will be having a look at this graph and we will see how to find the optimal value for the threshold. We will also plot the same graph for different modules and we will compare for which the area under curve is maximum. Alright, so for today, we are going to end the session at this point. If there is any doubt that you guys wish to ask, please go for it. I know the session has uh, been dragged for today, but it was necessary to understand this particular demonstration very well. Alright, if there are any doubts, feel free to ask your doubts in the chat box. Otherwise, you guys can leave the session. Thanks for connecting. Thanks for your time.